Hey, what's going on? Welcome to another episode of AngularAir. I am your host, Justin. And on today's episode, we are going to be talking about Angular and the JavaScript engine. We're going to get a little more insight into what JavaScript's actually doing, and looking forward to that. So let's say hi to our panelists, and then we'll meet our guest, and then we will get into the content. Joining us today, we've got Mike. Mike, what's going on?
Not too much. I was messing with my webcam, and I think I froze myself.
You did.
You did. We can hear you, which is one plus.
So what's new with me is I've been practicing ventriloquism, and I'm pretty good at it.
What's really good is you sound excited, yeah, but like your face looks.
When my camera does that, Mike, the only way to get it to fix is to quit Chrome. So just putting it out there, you might have to leave us if ventriloquist Mike is still here in a minute, but.
So it sounds like Mike will be back here in a second. Alyssa's with us. Alyssa, what's going on?
So glad to not be frozen. That was me literally like 10 minutes ago. So, hey, Mike fixed it.
Wow. I did it.
That was a close one. I don't know if we could have rolled with your frozen picture the entire episode. It might have been a little distracting. I don't know. Maybe not.
Yo, check me out.
There we go. You're the speaker. All right. And our guest today is Asaad. Asaad, how's it going?
Hey, good. Thanks.
We are very happy to have you here today. Do you want to tell our viewers a bit about yourself?
Yeah, sure. So I have like 17 years of experience in web development. I always loved computer science. My main experience was from the Middle East. I worked in Syria, Jordan, Lebanon, and the United Arab Emirates. And then I moved here to the United States back in 2014. I finished my master's here, and I was lucky to be able to work and stay in the United States.
Nice.
Yeah, I'm currently running a program, master's in software development. I'm the program director. I'm gonna give you more details about it later in the this session.
Awesome. And we're talking about the JavaScript engine today, huh?
Yep, we are going to talk about the JavaScript engine, how it works, how the stack, the heap, and how it generates machine code, and then how Angular takes advantage of how the JavaScript engine works to generate an optimized code. Pretty exciting stuff.
Yeah, it's really exciting. It's neat. I think that a lot of stuff as we build in Angular, we've got that abstracted away from us, right? So we're really, and I think a lot with Angular and the framework is you're thinking Angular a lot of the time, right? But really you're writing JavaScript, right? And so to have that kind of understanding and detail would be great.
Yeah, and we don't want to scare people off just mentioning buzzwords and big stuff. It's really simplified lecture, kinda. And it's meant for beginners, so everybody is can at least understand something.
Nice. Cool. All right. Yep. Well, you ready to dive in there?
Yep.
All right, let's do
it. Can I share my screen?
There should be a way, and then once Justin sees your screen share, he can add it to the stream. Yay!
There we go.
Awesome. I think we are online. All right, so what we are going to discuss today is the following. Let me get my pen here. First, we will talk about how the JavaScript engine works. What is the JavaScript engine? Next, we will see how it works. So basically, we write JavaScript code. This JavaScript code is first tokenized, converted to tokens, and these tokens generate what we call an AST tree, abstract syntax tree. Then this code goes into two stages of interpreter and compiler. We will see how these two guys work together. We will take another look at the JavaScript engine in terms of a heap and stack, how our code is organized and executed in these two guides. Finally, we will understand what makes a code JavaScript virtual machine friendly. Once we understand that, that will help me write better, more performant JavaScript code applications. After we set our understanding in the JavaScript engine world, we will see how Angular manages the change detection cycles. And then how can we optimize this cycle by writing better code? Pretty exciting stuff. As I mentioned in the beginning of this lecture, I work for MIU University. We have a Master's in Software Development program. This program requires no coding experience. Any bachelor degree is accepted. No need for computer science degree. We have a tuition guarantee policy. Our program is like 12 to 18 months, and you can waive 6 months out of this master's if you have an aptitude for programming. In this program, we teach both computer science plus software development courses. Of course, we teach Angular, we teach back-end technologies. So in the end, you kind of graduate as a full-stack JavaScript engineer.
Can I just say that your ability to write
Yeah.
are you doing that with the mouse? Like,
No, I'm doing that with the
Oh.
tablet.
I was like, that's really good. Okay.
I was just about to type that in the chat. It's awesome.
Yeah. Now, here is the exciting stuff. So we all know how meditation is like a really big thing and how powerful it is. And we all love computer science. How about we create a program that combines these two worlds? So in our university, we teach our students transcendental meditations, and that will help our students really excel in the computer science world. And they all succeed tremendously at their work. So that's it.
Okay, really quick, I'm going to have to request that we need to do an episode on that. If you want to come back and do another one on meditation computer science, I would love that. That would be awesome.
Yeah, I would be happy to explain to you how we do that, the structure of the block systems, and how our students meditate twice per day. It's just awesome.
That sounds amazing.
Yeah, our program, by the way, is the second largest program in terms of number of graduates in the United States. So, yeah. All right, let's see what is JavaScript first. So JavaScript is a very, very special language. It is built based on specifications from ECMAScript. We have very cool guys. They have a committee called TC39. These TC39 guys are the coolest guys on earth. They listen to the community, and they add new features to the JavaScript language. These specifications decide what the language is. So what these guys do is they say, hey, if we have 3 dots and then a variable name, then this is spread operator, for example. They say if we have an if statement and then a parent and then something, this is a conditional statement. Now, the implementation of converting this language into something that the CPU can run, it's the job of the JavaScript engine. So the JavaScript engine, basically, whenever I mention this word, JavaScript engine, is this kind of black box that we send JavaScript code to it, and in the end, we get machine code, something the CPU can understand. Now, there is a challenge here that CPUs are not unified. We have like M1 and AMD and Intel and other kind of CPUs. Now, most of all, basically, JavaScript engines support the different kinds of CPUs. So as developers, we don't need to worry about these low details. All we need to worry about is writing good JavaScript engine friendly code. And this guy is responsible later to generate machine code that runs on different kinds of machines. Google created the best ever JavaScript engine called V8. Basically, anybody, any developer can read this specification and implement their own JavaScript engine. Big companies like Google, they created their own open source JavaScript engine called V8. This guy is the fastest so far. Mozilla also, they created a JavaScript engine. They use it in Firefox called SpiderMonkey. Microsoft, they have Chakra Core. Not sure, maybe they have dropped that. As I understand now, they use Chromium. Apple, they also have their own JavaScript engine, JavaScript Core. All of these guys, they have the same black box. These JavaScript engines, they receive JavaScript code, and in the end, machine code is generated. Everybody can check the source code of the JavaScript engine V8, and hopefully more developers will contribute, helping the community, adding a new feature to this JavaScript engine. I explained the things. Now, let's take a look at the difference between an interpreter and a compiler. When we have a black box that translates a language to another language, which is JavaScript to machine code, this translation is the work of an interpreter. And JavaScript engines, they have an interpreter that does this work. At the same time, we have also another unit called compiler. So the JavaScript engine is pretty unique. It has both an interpreter and a compiler. The difference between these two is that this guy runs the code just in time. Just take the JavaScript and translate this to machine code. Now, this guy has two parts, two compiler parts. And this part's job is to kind of look at this code and try to optimize this code, run this code ahead of time to create a better optimized code. I will explain this process in details in the coming slides. Don't tell me Yoda is not cool, because it is. I never learned anything about Star Wars characters until like a month or two ago. It's never famous in the Middle East for some reason. But a friend of mine, he was like, "Oh, Asaad, you have to watch." And I started watching like Star Wars movies from the first one in the 70s.
Mhm.
And when I saw Yoda, I was like, wow, this guy is the wisdom, the best. So now in my slides, you will always see Yoda and Star Wars stuff.
It's a slippery slope. Be careful.
Yoda taught me a lot as a kid, so yeah, I can appreciate that.
Yeah. All right. So I will start here, basically. That's how the V8 engine works. We write simple JavaScript code, var x equal 5, semicolon. This code, when it enters the JavaScript engine, first is going to be parsed. The parser part job is to create tokens. These tokens basically analyze all the code that you have written. Let's take a look at an example for this guy. That's probably going to be a challenge to open that link. Right. Yes, you can see that. Good. Here is an online AST visualizer. Before we see an AST tree, let's we write some sort of JavaScript code here at the left. And as we can see, we have a parser that parsed my code into tokens. So we have a keyword var identifier A. Then we have the equal assign punctuator.
This is the coolest website ever.
Yes, super cool. And as you can see, all my code has been parsed into tokens. Now, if for any reason you have written some wrong syntax, at this stage, you will immediately see a syntax error in your when you run your code. So basically the cycle doesn't continue after that. The parser analyzes the code into tokens. If there's any mistake, that's when we stop, and yep, we will realize that there is syntax error, and users immediately see that this code cannot be executed. Now, after we parsed our code into tokens, these cool guys, it is sent to unit to build an abstract syntax tree. Now, this is computery sciencey concept that we take all these tokens and try to build a tree from these tokens. Why we do that? Because some people decided that parsing this tree is simple and easy and help me translate a language to another language. This is just simply how translators work. When I translate something from English to French, I would do the same thing. I have a verb, I have subject, I have a pronoun, and I will just translate this. So in order to do that in the computer, we just parse the code into tokens, build this abstract syntax tree. Now this tree is easy for the computer to take this, parse this from the root all the way down. My mouse is super sensitive. All the way down, and maybe I should refresh. All the way down and generate machine code based on the CPU type that you have in your machine. Nice. So after we build the AST tree, back here. Now this tree is built, tokens, tree. This is basically how the tree looks like. This is one node of the tree. It tells you, hey, we have a program that has a variable declaration var, and then we have a variable name called x, and we have a raw value called 5. See that? And yeah, that's basically my simple program.
So I've been diving into the C#.NET world lately and learning a little bit about Blazor. Does it have its own parser and engine and or is it pretty much the exact same process? Since it runs on the web, I assumed it was.
Should be, yeah. And most programming languages should have some sort of tokenizer and abstract syntax tree before they are kind of interpreted or compiled like Java and other languages and C#. Cool. But JavaScript is like kind of unique. It can be interpreted and compiled. I will talk more about this process. Now, anything like weird here to look at and notice? Yeah, we don't have types, right? Basically, you can assign anything to this x. When we are like, hey, I want to put 5 inside this x, 5 is basically means nothing to. I can later replace it with an object or an array or string or any other types. So we don't have information about the types. And this is very powerful feature in JavaScript. Some people, they would think, oh, that is like kind of confusing and not safe and blah, blah, blah. But I find this feature pretty powerful if we understand how we use it in a responsible way. So with power comes responsibility. All right, we have the AST code. This AST code goes into an interpreter. In V8, Google JavaScript engine, this interpreter called the ignition engine. They choose the coolest names. AST goes into the ignition engine, and we receive bytecode. CPUs is happy, and they can run this code. I can assign 5 to X, and we call it a day. Now also we have some sort of here magic happening, looking at the code that the interpreter has generated, and we're kind of looking at areas that execute more often. This unit is kind of looking for stubs. Stub is an area of code, a line of code that runs more often. And now this area is kind of marking these small pieces of code as, first, we mark them as warm if they exceed a certain number of calls, and then they become hot if they reach to a certain number of calls. Let me give you an example here. For example, we have this function that runs, and I have here a for loop. As you can see, this line of code is going to run array.length times. That's cool, but we don't know the number of this array. If this array is, for example, has 1,000 elements, at first, this line of code will be marked as warm. Let's say, for example, when it reaches 100 calls, and then any more calls for this specific line, now this guy, here the compiler, mark this line of code as hot line of code, and it will try to optimize the code of how this code is runs. Now, this optimization basically can only happen if I have monomorphic code. Big word. Let me explain what all that means. In order for us to run this line of code, execute this line of code, as we explained earlier, values, variables, they don't have types. Basically, in order for me to execute something, I need to understand the type. So I can know that 5 plus 5, number plus number, this is addition. If I have 5 plus string 5, now I'm having some sort of concatenation between a string and a number. So we need always to understand what the type before we can generate bytecode. Now, the generated bytecode for a code that we don't understand the types is going to be long enough to check every single combination of types that we might encounter when we run any code. This can be Boolean, this can be string, this can be an object, so we need to stringify the object and then convert the string maybe to another number. A lot of possibilities. So the generated code for out of the interpreter is going to be unoptimized, but it's pretty fast because just in time. I receive the code, immediately generate bytecode. Come back here to this line of code. We have here this line results plus equal array I. First of all, we need to understand if I is an integer or string or something else. Next, we need to check result because I'm trying to have result equal result plus the value of this condition. So I need to check results is a number, string. What am I trying to do here? Because I'm trying to have a plus operation. Plus operation can be addition or can be concat. Next, I need to check the array itself. Does it exist? Is it really an array or probably an object, something else? Next, we need to evaluate array I and see what the data type of this operation. So as you can see, executing this line over and over and over, especially if we don't know the types, we can create some sort of an extra checks that are not necessary, especially when I'm running this code for 1,000 times. So this checks is out of the interpreter and optimized. An optimized code can look always to the I. Oh, I is always happening as an integer. So we don't need to check the type of I. It can look at the values that come from the array. Oh, so far I had 100 calls, and all the values from this array happen to be numbers. So why I always check that? Optimized code, if let's say an interpreter generates 1,000 lines of code just to run some simple statement, an optimized code can be just like 50 lines, not 500, 50 lines. And as you can imagine, this code will run faster inside the JavaScript engine in the CPU than going through all these options every time I need to run certain code. Now, at any single time we face a new type, let's say here in this example, I find that array I always give me numbers. So I optimize the code to run only on numbers. We push different code to the CPU now. Now, at any time this type changes, immediately we revert back to the unoptimized code. Now, developers don't need to take too much pay too much details about how is that work, but they need to make sure they understand simple rules of best practices. What is best to do when I write JavaScript applications? One simple rule is don't change object shapes. So if you create an object, never mutate this object and change its structure later. If you have an object with X property and some values, keep it like that. Don't add later at runtime another property to the same object. This is bad practice. If you do that, your code will be JavaScript engine-friendly code. Another thing that we need to look at is, hey, we like to keep our function arguments always monomorphic, same type. Let me run an example to show you what I mean here. First, I find this code is pretty funny. So we have here a condition: if a equal 1 and a equal 2 and a equal 3, then we should print wow. Let me run this code. Is equal. I'm running this code, and if I check my console, we see wow. So basically, A was evaluated to 1 and 2 and 3 at the same time. How did that happen? Well, simply because A is an object. And when A equal 1 was trying to be evaluated, an object needs to be stringified. So toString method is called. A object has I and toString. So what I did is I override the toString method that need to be used when we execute when we stringify the object A. So at first, A is evaluated to. When toString is called, we increase A.I and we return the value. So A at first will be 1, and then it will be 2, and then it will be 3. Not understanding the types is big problem. Another example. I have created here an array that has different types. Sometimes number, sometimes string, other times Boolean. And then I want to create an array of 10,000 elements. I call my array tests, and I fill this array randomly with all these values. So if I want to see what's I have, let me see. Okay. All right. Let me run this code and let's take a look at tests. Node.js. You can see I generated 10,000 elements array that has random values of sometimes Boolean, sometimes string, other times numbers, and so on. Now let's try to measure something here. I created a function that will accept 2 values and return value 1 plus value 2. We know that the plus operation can be either concat, can be either additional operation. We don't know. It's based on the type of these two. When we don't know the types, the code will execute in longer time. What I did here, I started a timer and I ended the timer after finishing this for loop. I start a timer and then I'm going to loop over this array and add basically every 2 elements together. I'm calling plus on the first element and then the second element. Next, second element, third element, and so on. I just want to do some sort of calling the function and see how much time it takes to go over the entire array and add the elements when my elements have random typed values. Let's take a look at the execution time. It took like 900 milliseconds. Good. Let's run it again. Almost 1 second. 1 second to just add every 2 numbers. The JavaScript engine basically cannot optimize this code. Every single time we call plus, oh, now I have string and number. Next, I have a number and Boolean. Next, I have string and string, so concat. This code is not JavaScript engine-friendly code. What happened if I replace my array with single-typed elements? So basically, my array will just be random numbers. All of them are numbers. That's good. That's good. We managed to cut the time kind of in half, from 1 second to 600 milliseconds. The reason is when the JavaScript engine was running this plus, a lot of times it managed to check, oh, all I'm receiving is the same type, numbers. So it was able to optimize the code in a way that we don't need to check the types anymore. And now my code runs almost 50% faster. That's awesome, isn't it?
Yes, it is.
Thanks. Thanks for answering.
I had to find my unmute button. It took me a second. You're like, is it awesome? Yes, it is.
Awesome, yeah, I know. All right. Now that we established that, let's take another look at the JavaScript engine really quick. Now, when your code runs, we can look at the V8 as that has two data structures, stack and heap. I don't know why I have this thingy here. Okay, let me change to 10. All right, so the heap is basically memory space. Wherever you define variables, X, Y, Z, all of these people, they live in the heap. And whenever you run your code runs in data structure called stack. We start with the global execution context. And every time we call a function, we create another execution context. This stack basically has data structure called first in, last out, philo. Sometimes people, they say last in, first out, or LIFO. It's the same concept. Basically, this guy needs to be finished before we return back to this guy. And function in JavaScript defines a new scope. So here we have our variables in the heap, in this space. And when create invoice executes, it uses references to these variables. And when it's done, these variables need to be cleared out from memory for more code to execute. Now in V8, we have a mechanism to clear up memory. This mechanism, we call it garbage collector. And in V8, it's called Orinoco. Pretty cool. This guy, garbage collector, job is to simply mark all the spaces that are not used anymore from any execution context and free up spaces in memory. The algorithm to do that is called mark and sweep. We start from the root node and we scan all the nodes that still have references in our execution context. So we mark this guy, this guy, this guy, this guy. Now all the other spaces in the heap can be cleared out. So as developers, we not only need to write JavaScript friendly code in terms of monomorphism, same type, but also we need to make sure that we don't cause any memory leaks. When can we create memory leaks? Global variables is one of these. Thankfully, now we have JavaScript modules that wrap all my code in kind of a local environment, so we don't expose any code in the global scope. Next, we have event listeners, intervals, and timeouts. All of these guys, they create objects. And this object will always have references to some data in the heap. And if we not remove the event listener or clear our interval and clear our timeout, these references stay in the heap and will cause memory leak. So imagine a component that does a lot of events from elements. And for example, you create 5, 6 observables, and then you're traveling between many components within Angular router. If we don't clear out these observables, every single time you revisit this component, you create more observables and more observables and more event listeners. And at some point, your application will use a lot of space in memory, especially the heap, and your application will run out of space because this is limited amount of memory. So we always make sure we like to remove listeners, intervals, and timeouts. And every time I remove DOM elements also to remove the associated event listeners if there was any. Same with the call stack. We need to be careful when we execute more and more and more code, not to fall into some sort of problem of Stack Overflow. This is different than the stackoverflow.com. This is basically saying is we don't want to call same function in a recursion way, so it just fill out my stack, so we cannot execute any more code in our JavaScript engine. So, best practices is never mutate and change object types. 2, use the same types when we call functions. Now, we have a language that kind of enforce these 2 best practices, which is TypeScript. TypeScript, by default, when you declare a variable, you have to assign a shape for this variable, a type and a shape. So you cannot change the shape later. Thank you, TypeScript. Also, when you declare a function that has x and y, you enforce that this guy is a number and this guy is a number. So you cannot call this function at any time in your code with different types. So another thank you to TypeScript that enforces both of these best practices. Now, the Angular team, when they decided to create Angular, they wanted to write very performant code, VM-friendly code. That's why all the source code of Angular is written in TypeScript, because it gives me a lot of power enforcing and generating faster code that run in the V8 that can be optimized later via the compiler. So it's not only giving safe code, so we don't safe code means not passing different types of variables into the function, but also this function can be improved, optimized, and run faster in the compiler. Now let's talk about Angular a little bit. Angular has something awesome. I'm gonna run a quick example so we don't exceed the time. Okay. Here I have my terminal, and here I have my code. Here is a simple application that generated via the via the CLI. Let's get rid of this stuff. I have a template. So in Angular, a component has 2 parts. We have the instance, the object. This is where our state lives. And we have the view. That's what Angular is going to create at the browser in the DOM. What we can do is we create data binding. So we bind a property to be displayed at the DOM. This binding tells Angular, hey, we have this state. Please take this guy and create an h1 at the DOM and display the title. Nice. Now, the magic of change detection is Angular needs to know when this property changes, so it updates the DOM. When does that happen? It happens only when we have events. Let me create a button that's change, for example. And let me add an event to this button. So when I click this button, I want to change this title to say something else, and I'm gonna set title to become Asaad. Happy about that. Identifier Asaad is not defined. It's gonna try to evaluate this guy. So let me convert it to string. All right. Let's test this code. ng serve. And this is the first time I'm running this code. It will take a minute before the compiler converts.
What's the -o flag?
To open the browser when this serve is finished. So my browser will open automatically. So we have AngularAir. When I click change, I see Asaad. Now this is kind of magic. It sounds like very simple things, but it is magic, because all I did is like I managed to change a property value. Even if title was an object, let me show you. Change this title an object, and let's display title.x, and let's set here title.x to Asaad. How my Angular application will change. Oops, another magic. So what I did technically is I mutate a property inside an object, and still Angular was able to detect this change, know that one of my object properties changed its value, and it went and generated a new DOM value for this heading element. Now, the way Angular does that is by using zones. And the way zone works is by kind of interfering with every single asynchronous event, like Ajax call or DOM event or timer. All of these events, Angular try to look at these events, and whenever they execute, at the end, it triggers change detection. It has an algorithm called defer algorithm. I'm not going to go into too much details here, but I can show you that we have two kinds of defers, iterable and key value defers. One of these for list-like structure, and the other for dictionary-like structure when we have key values. And this zone basically tell Angular, hey, Angular, please, we have an event that happens, which means you need to recheck all the components trees, go over all the properties values, scan deeply every single object, whether we have a different value. Now, when Angular finds out that X was AngularAir and then it becomes Asaad, then it goes to the DOM and patch the DOM efficiently. Accessing the DOM tree as developers is very risky and expensive. So many people, they don't understand what this expensive mean. It's not in US dollars or Bitcoins at all. Expensive, when the DOM tree is built with mind of pre-calculated properties. So if you have an array, we have pre-calculated property called length. Every single element have pre-calculated properties to know all the children and the parents of this guy. So whenever you use document.querySelector, any kind of way to access or change or mutate the DOM tree, this is an expensive operation because it requires changing a lot of properties in the DOM tree. As developers, yes, we are the best, I know, and I understand this fact. But when you build an enterprise web application, you will be lost. You will be completely in trouble finding out what is the best optimized way to change and access the DOM tree. And that's where frameworks like Angular shine. Because let me show you something cool. Pretty simple, but cool still. whenever I inspect this code, oh, I don't need this guy. Oh, not this guy, too. All right. When I click the button, you will notice that only the text inside the H1 has changed. See that? It targeted only the H1. It never changed anything else. So technically, Angular really knows how to patch the DOM very precisely and access the DOM minimally, just the element that has changed. This is nice. Now, the best news to end this presentation with is Angular generates change detection algorithm code that is VM-friendly, monomorphic code. So the genius guys that created the framework, they were like, hey, let's design this change detection stuff, logic, having in mind it's always monomorphic. The function that runs and scan and defer and all this stuff is monomorphic, always runs with the same type. And we just saw a demo. When we call a function that accepts variables with the same type, it can be optimized and run really, really fast in the VM. So we technically can run hundreds of thousands of checks in few milliseconds. We don't need to worry about that. Thank you, Angular team. We appreciate that.
Yes, very much.
Yep. And when they designed also this algorithm, they didn't require developers. Hey, Mr. Developer, in order to do a change to your application state, hey, you must create always a new reference to title. No, you can just mutate title. Hey, in order to change title, you have to call set state or set block. We don't do that. We leave changing the states freedom. We give freedom to developers. We don't enforce how the state is changed. The framework is designed to take advantage of the how the engines work, how the code can be optimized, and it will detect the changes and run these very, very fast. Despite that this algorithm is really fast and great, and we love it, we can still optimize the code further by using always immutable data structures. So basically, I enforce that this title object is always going to be immutable. So we never mutate its values. We can enforce that by using some libraries. And in this way, we can stop the change detection cycle whenever we have like big tree of components. So if I have, for example, Angular app, Angular application, and we know that Angular application is a tree of components nested. Each of these components, they have states, and I have a lot of lag, which is fine. Angular always scan this tree and then generate DOM elements. I need to write slowly in order for this. All right, that's fine. Now, whenever we change one of these guys, Angular does the magic, change detection, scan this tree, figure out what has changed, and then only patch minimally the DOM, what's need to be changed. Now, what we can do is, if this component uses immutable data structure, we can stop the check that happens on this component. We can do that by marking this with property called onPush. I have a lag, which is fine. We can mark a component, hey, I want to change detection strategy to be onPush. We tell Angular that basically we don't want to have this component to be checked whenever you run change detection cycle. But in order to do that, you better have immutable data structure, and you better listen on ng on changes hook. Because ng on changes, whenever you receive a new reference, it will be called, and you can basically patch whatever you need whenever you need. So basically, we can optimize the code to run faster. Yes.
Clarify one thing. So you mentioned that if you set a component to be the change detection strategy of on push, that it changes that component. But to clarify, doesn't that also say that all of the children of that component are also therefore wouldn't change because everything underneath is on push as well?
Awesome. Yes. Correct.
So it's not just, hey, you get that optimization for that one component, but you're taking out a potential large chunk of a tree at a parent level.
Yes, that's awesome. Thank you for that. So if the root node for this branch is marked as on push, so basically all the children of that branch, we kind of cut a branch of the tree that takes care of its own updates, which is awesome. Very good boost to the performance of the change detection. Yeah, with that, I kind of run out of slides and time.
Awesome.
Yes.
That was a very deep dive journey through. Oh no, we lost him. Asaad, come back. Alyssa, you're muted.
Everything's going to
Everything's crazy.
I wonder if he had epic lag. So I wonder if something was running on his machine and like just crashed maybe. So that was awesome though. I really enjoyed having him on. I know you guys have to go.
I'm back.
There we go. It's back.
I clicked something.
Real quick, because Jeff asked the question in chat whether or not you should avoid using on push on child components. No, it's still a good idea because remember with components you get reusability. So if I have a parent and 2 levels down I have a component that if the parent one has on push, it doesn't mean you shouldn't put it on the child component because there may be other components and it could be reused elsewhere. So that wasn't a question. It was a clarification. Yes, true. Because of reusability components, it makes total sense.
Oh, everyone
Sorry.
loved having you on. Chat was going crazy with your praise. So thank you so much for coming on and sharing this with us. It was really good
That was
presentation.
great. That was great.
My pleasure. Yeah.
All right, let's do some quick picks and then we'll call it a wrap. Our panelist, Mike, I think you said you had a pick.
It does. So it's 2021 now. And the sad news is that at the end of this year, this calendar year, Google's support for AngularJS is ending.
Yay.
Justin,
Wait, is there any good news?
there is. I mean, there are ways of getting extended support beyond that, but I don't want to turn this into a commercial. But you can read about the AngularJS end of life on the AngularJS website.
Oh, come on, Mike. Give us your best ShamWow. You can
I
do
didn't
a
want your
commercial.
commercial
I'm not
now.
ShamWow, no. I'm part of a team that's offering extended long-term support.
What's that team
beyond
called, Mike?
2021. So
Can
take
we-
a look
can
if
we
you
name?
still run AngularJS.
All right, cool. Alyssa, do you have a pick today?
Yeah, I shared the Twitter link with you. Me and some friends are starting a podcast called Devs and Dragons, where we invite a developer on and we play board games on Steam with them and kind of get to know them and hang out for a couple hours. So it's new. If you go to the Twitter's channel, it looks pretty barren because we literally just started it. So look for some fun episodes coming up.
Now, to clarify, are we talking podcast or is this an interactive stream where people can follow along live?
Interactive stream, but then the recordings are available later. Does that not count as a podcast if it's live?
No, I was just curious.
I don't
at
know.
that aspect of it. That's all.
Yeah, we'll stream to we're planning to stream to both Twitch and YouTube at the same time, live, and kind of interact with the audience and take questions. And then they'll be available later for watching. So That is all. That'd be-
So how do we get to be a contestant on that? Because I mean, I remember back in the day when I was a kid, I'm like, I want to get on Wheel of Fortune, and what do I got to do? Do I send a stamped envelope somewhere? Like,
Don't
how do
worry,
I become a
you
player?
three are already on my list of like people I want to invite. So yeah, you, Asaad, Mike, you're on the list. You should be getting invites, but we're just kicking it off, so moving pretty slow right now. But
I'm
yeah,
ready.
look forward to it.
There we go. There we go.
Mike.
All right, I got 2 picks. So along that same lines, Jeremy and Steven from the Angular team have been streaming, playing games and talking Angular. I have not got a chance to watch it yet. I think that they did last night. They were doing Minecraft. I really wanted to hop in and check that out, but they've been tweeting it out about it. So I don't have a link or anything, but maybe check the Twitters and
Can I
follow.
help?
Yeah.
I watched last
Mike.
night.
Okay, how was it?
They were playing Minecraft and they were talking about Angular and they were talking about Dev, and it was really cool.
Do you know if they were like if the recordings are available? I didn't even know this was a thing.
Demos with Angular on YouTube.
On YouTube, okay.
All right.
I got invited to play next week.
I want to play. What are they playing?
They haven't decided.
Oh, all
Oh
right.
my gosh, I'm so excited.
That's cool.
That's cool.
That's cool. All right. And then my second pick is StreamYard. StreamYard is gracious to host and support us in our efforts for bringing you the show. It's browser-based streaming meeting. It's very awesome. Makes it real easy for all of our panelists and guests to just hop in here and join. I don't need an account. Can do it all through your browser, and we can bring you this great content. So big shout out to them. All right, Asaad, do you have any picks that you want to share?
Yeah, certainly. I would like to definitely mention our website for our program, the Masters in Software Development. So check out our website, mst.miu.edu, to have more information about the program. We are currently accepting applications for the next August entry. And here is the courses and curriculum. And here it is, Angular course, where we teach Angular in details. In course we called Web Application Development. You will be able to build your final project using Angular. And we will teach you in details everything about the JavaScript engine and Angular and more awesome stuff. So yeah, that's my pick.
That is very cool. And meditation too, right?
And meditation.
Nice. We definitely want to try and do an episode on that. That'd be great if we could coordinate that. We would love to learn about that.
Yeah, sure.
All right, cool. Hey, Asaad, thanks a ton for coming on, sharing your time, sharing your knowledge with us. We really appreciate it. And your teaching methodology was amazing. I learned a lot. So thank you very much.
My pleasure. You're welcome. It was a pleasure to meet with you all again, and we'll catch up soon.
For sure. For sure. All right, that's a wrap. Thanks everyone for watching. We'll catch you next time. See ya.